is procedure for multi-lane highways and uninterrupted flow facilities, which contains multi-lane highways and basic freeways. Okay, and all types of freeways actually, and we are going through this procedure. We have talked about free flow speed. Okay, we have talked about how to calculate capacity, how to adjust the volume, how to calculate the speed. Okay, and then from density you can find out the level of service. Okay, so this is for the free flow speed. If you cannot measure it, you can use the equations. There are equations for capacity, and the capacity may have to be adjusted according to the site conditions. This is to find out the demand flow rate. So you need peak hour factor, number of lanes, and the heavy vehicles. Okay, for the heavy vehicles, you have to calculate from this equation. This equation requires ET, and which is the equivalency factor depending upon the type of terrain. Okay, and these are the ET values according to type of terrain. We looked at this example, very simple. Yeah, so when you are calculating the speed, you have to find out what is the break point, the point after which the speed starts to reduce. So before this, the speed equals to free flow speed, which is this one. Okay, and after this, you have to use this equation to find out the actual speed of the road under your flow rate. Once you find out the speed, calculate density and find out the level of service. These are the values for the graphs which they already plotted. Okay, the capacity and the speed at capacity. We did this example, find out the level of service. Okay, and then we talked about the adjustment factors. Okay, so this table gives you the adjustment factor of speed and capacity because of what? Weather. Okay, and for the speed and capacity adjustment factor because of work zone, you have to perform a series of calculations. First of all, you need to find out the Q discharge rate, which needs certain factors. Other factors have a value between 0 or 1. Okay, only the lane closure factor has to be taken from this table. Once you find out the Q discharge rate, the Q discharge rate can be used for calculating the capacity adjustment factor, and this is the simple capacity which we have already seen in the previous example. And so this will give you capacity adjustment factor. Then for the speed adjustment factor, I need free flow speed in the work zone. Okay, so again, most of the factors are the same as the Q discharge rate equation. The only new factors are speed limit in the work zone and the ratio of speed limit work zone without work zone, which is FSR. Okay, so speed limit in the work zone and normal speed limit, their ratio is FSR. So these are the only two new things you need. Once you find out the free flow speed of the work zone, you will take its ratio with normal free flow speed and you will find out the speed adjustment factor. Okay. This was about the capacity and the speed adjustment factors. Again, we covered them in more details in the traffic course. There were examples for work zone factor and whether how to use a weather factor with the level of service. Okay, so we are not going in the same details again. So this one, a new suburban freeway is being designed in level terrain. Heavy vehicle factor is given, peak hour factor is given, free flow speed is given. Freeway needs to accommodate 4,000 vehicles per hour in the peak hour. How many lanes are needed to provide level of service D during the peak hour? And if we change to level of service C, then how many lanes will be required? Okay, so what was the first thing? What was the first step? Find out the free flow speed. Is it given? How much? 65. Okay. What was the second step? Capacity. Okay. Capacity can be calculated using the free flow speed. We are dealing with the freeway, so the first equation, free flow speed is 65, so the capacity is how much? 2345. Okay. So we found the capacity. We should check if it needs any adjustments or not. Okay. We have known adjustment can be because of weather, incident or work zone. Did they mention any incident here? Any weather conditions, any work zone? Not mentioned. Okay. So no adjustment required. We'll move on. What was the next step? Peak flow rate. Okay, this is the equation for peak flow rate. What do I need here? Peak hour factor, is it given? Peak hour factor, given, right? It's given. Okay. Number of lanes. Number of lanes. Number of lanes are given? No. We have to find out, right? N is unknown. Okay. What about FHV? Given, right? Okay. So now there are two unknowns. Volume, what about volume? Volume is given? Volume is given. Okay. So there are two unknowns here in the equation. One is N and the other one is VP. Without N you cannot find out VP. Okay. So what should we do in that case? What else is given in the question? What else did they give me? Yes, tell me. Level of service is given, right? Level of service is D. Or we can check it for C as well. Let us start with D. Okay. For level of service D, what do I know? Density. Every level of service has a density. Okay. So density at level of service D equals how much? 35. Okay. Now what is the relationship between density and flow rate? I'm trying to find out flow rate, right? Yeah. So density equals Vp upon S. Okay. Clear? Now, do I have an equation for S? I have an equation for S, right?
Second equation.
Yeah. Second? I know the first.
Because the new surface D after breakpoint.
Okay. Then I find out the breakpoint. I can find out the breakpoint, right? So how much is the breakpoint? Well, I only need free flow speed, right? Free flow speed is 65. So my breakpoint will be how much? What do I do with SAF and CF?
1.
1. Okay. No adjustment means 1. Okay. Because I still need breakpoint in the equation as well, right? I still need the breakpoint here. So how much is it?
1,400.
Okay. To use the equation, Vp must be greater than breakpoint. I don't know I don't know Vp yet. I don't know Vp yet. Okay. So I'll use this equation to find out Vp. Okay, the speed equation. Speed equals to what? Speed equals to what?
dV upon d.
Do I know speed? Do I know speed?
No.
We don't know speed, right? Okay, so I have to get rid of the speed from here. So speed equals to what?
dV upon d.
Vp upon d. Okay, I don't know Vp, but I know d. Okay, so S can be replaced with Vp upon d. So the whole equation will have only one unknown, which is Vp. Clear? Okay, I replace S with Vp upon d. D is 35, Vp we want to find out. So the whole equation will have one unknown. And what is that? Yes, how much? What?
Negative.
Huh? Why?
So 1,277.
This is not included, right? And capacity is 235. What?
E squared. 1 squared. C times F.
Minus? Minus?
Minus 1,277.
1277. 74. 1277. Yes. But minus. That means our assumption is wrong, right?
Yes, it's the first one.
Yeah, it should be the first one. That means our assumption is wrong. What was our assumption? That this is more than this. Okay. Now you are not getting, even if you got a positive value and it was less than BP, we're still not accepted, right? I have to go to the first case then. Okay. So my speed equals to what? 65. Okay. So now I know density, right? I know density. So if speed is 65, then my Vp is how much? I'm using this one now. Okay. I still have to find out Vp, the flow rate. That was the main question here. So I will use now d into s. D is 35, the density for level of service D, and S is the free flow speed. I know it from here. So how much is it then?
2275.
It's more than 1400, huh? There's another way of doing it, but we did not discuss it here. Okay. Okay. Let's do the other way around. Okay. Okay. Pay attention. Okay. Whatever we have calculated, we still need it. Okay. Whatever we have calculated, we still need it. Okay. Moving on. So what do we know? We know BP is this much. We know free flow speed. Okay. And we know capacity, right? We know three things. Free flow speed. Free flow speed was given 65 miles per hour. Capacity we calculated 2350. Okay. Give me speed at capacity. In this equation, I'll put what equal to capacity? I want the value of speed when the flow rate equals to capacity. Vp equals to capacity. So how much is the speed? $52.2. Okay. Why did we find out these values? So that I can plot this curve. Okay, I found these values, so I can plot this curve. Okay. So this curve starts from what? Free flow speed. Okay. The flow rate is 0. The speed is free flow speed. Okay. Till what point it will continue? No. Like this, in a straight line. Break point. Okay. So I will start from here. I'll keep on drawing a straight line until I reach how much? 1400. Okay. So from 1400, then it will start to go down. Okay. That will go down up to what point? Okay. So this is my x value and this is my y value. Clear? Okay. Now I need one more point. To complete this curve, I need at least one more point. Why? You know the break point, right? You know the capacity. Now I'm saying I need one more point. In between them, so I can make a curve, right? If you join 2 points, that will be a straight line. Okay, so I need at least one more point. Any point will do, right? Any point between these two values can be done. Okay, let us take 2000. Okay, so give me the speed. I'm just taking randomly because I just want to make the curve. Okay, so S at 2000. How much is that? VP 2000. VP 2000. Capacity same. 2350. Okay. What? put Vp equals to capacity. Okay, so I can now I will make this curve up to breakpoint, make this line up to breakpoint. After breakpoint, I'll plot this point. Flow rate 2000, speed 59.9. Okay, so I'll make this point between the breakpoint and the capacity. Okay, the next point will be the capacity and this is speed. Okay, so this value on the x-axis and this value on the y-axis. Okay, so now I have 3 points. I will join them. It will be a curve. Okay, so this curve is complete. Okay, starting from 0, ending at capacity. The curve is complete. Okay, so on these curves, then you see these lines, right? Which line do I want? The level of service? D, right? So I want this line. Okay, I want to see where this line will intersect my curve. Okay, so this line has a density of 35. Density equals what? Vp over S, right? Okay. So I can go to this point. Oh, sorry, I don't have the point. So I want the slope of this line because I know it starts from here, right? Okay. What will be the slope of this line? Slope equals what? Y over x, right? Okay. So y is speed, x is flow rate. Okay. So, and what do I know? Vp upon S. I know density, right? Density is what? Vp upon S. And the slope is S upon Vp. Okay, so I'll take the inverse of 35, which is how much? 0.03 is now what? Okay. 0.03. Okay, so this is my slope. Okay, I will find out the value of A and draw a line at this angle. The point where the line intersects the curve is my Vp. Okay, the point where the line intersects the curve is my Vp. Okay, you start from 0, you will get the angle from here. Okay, and you draw the line. The point where the line intersects the curve is my Vp. Okay, so for example, this one, not this one. Okay, this is a line, right? So let's say, I'm just giving an example. Let's say it's 1700. Let's say 1700. Okay, so 1700 is what? My Vp. Okay, I'm trying to find out what? Number of lanes. Okay, so now I will go here. I know peak hour factor. I know FHV. V is already given in the question. Now Vp from the graph. Okay, so I will find out what? Number of lanes. Clear? Clear? Okay. The question also says what will happen if the number of lanes are changed to, if the level of service is changed to C. Okay, so what will change? Tell me. Huh? Yes? Capacity? Capacity changes? Density changes. Okay, so now you have to draw a line for level of service C. Same thing. Now we'll take the inverse of 26. Okay, so it will give you the slope. Again, it will start from 0. You already plotted the curve. The curve will not change. The curve is from 0 to capacity. It will not change. Level of service A, B, C, D, E, all of them are here. So now you will draw a new line for level of service C. The intersection point will give you a new value of Vp. It will be less, obviously. This Vp will be less, right? This one, yeah, less. Okay. So again, then you will go to the equation of Vp, put that value. And you will calculate number of lanes. Okay. Clear? Any questions? Not now. Huh? Okay. What? Yes.
Clear.
Yeah. Okay. Up till now, what we have done is basically, we can't call it a revision or a summary or whatever. We discussed it and we covered it in more details with more questions in the traffic engineering course. Basic freeways and multi-lane highways were covered there. Okay, we did more examples there, including an example like this. Okay, the whole graph was plotted, the VP was found, and everything. Okay, and there are more examples with the adjustment factors as well. Okay, so have a look at them, but you didn't have a look at them when you were studying traffic. So now have a look at them. Okay, it will be something new. Okay, but this one was not covered. Okay, this part was not covered. So pay attention. Okay. So then we have on the freeways. Freeways don't have intersections. They have what? Huh? Ramps. Okay. So these ramps, the area or the point or the segment which has a ramp, it can either be a merge segment or a diverge segment. Okay, a merge segment or a diverge segment. Merge means what? Entering. Okay, so it's an on ramp and you are entering the flow, and diverge means it's an off ramp and you are exiting the flow. Okay. The merge segment and the diverge segment, they have an influence area, or let me put it the other way around. Every ramp has an influence area. Okay, and thankfully they have found the value, the distance up to which the ramp can influence the flow. Okay, from research. So they are saying the immediate two lanes of the ramp, up to a distance of 1500 feet. This is called the influence area of the ramp, whether it is on ramp or off ramp. Its influence area is two immediate lanes up to a distance of 1500 feet. Okay, so it's an on ramp, so people will enter from the ramp, right? So they will affect the flow after the ramp, right? No, it's an on ramp, right? So people who are coming from this ramp then influence the freeway where? After or before? After, right? So 1500 feet after for on ramp. Okay. Now this one is an exit ramp. So people who are going out from the ramp, they will affect the flow before or after? Before. Okay, when they are exiting. So before. Again, how much? 1000. Okay. Clear? And they are saying this these two lanes are under the influence area. So 1500 feet in these two lanes is obviously having the influence of the ramp. Okay. What else? Yeah. You can see the 1500 feet is measured from this point where the ramp is touching or is diverting from the road. Okay. Same here. Okay, for an on ramp it is this point on the left hand side. For an off ramp it is this point which is on the right hand side. They call it the gore point. Okay, so the influence distance starts from the gore point. Okay, so it is the, for an on ramp it is the first point of the ramp where the ramp is in contact with the highway. Okay, this connection point. For an off ramp, this is the end point. Okay, this is the end point of the ramp, right? And this is the start of the ramp. Okay, so for on ramp start, for off ramp end. We call it the gore point. So distance is measured from the gore point. Clear? Okay, what else? For merge and diverge both segments. So we are talking about this gray area. Okay, we are doing the analysis for this gray area now. Okay, outside the gray area is called basic freeway. the one which you already covered. Okay, the analysis which we have done up till now with multi and highways, they are for basic freeway segments. Okay, if you go back to the definition of basic freeway, it was part of the definition that basic freeway are outside the influence of the ramp. Okay, so when you are in this area, you don't have basic freeway. You have either merge or diverge. Okay, the procedure for both these types of segments is same. Okay, the procedure for calculating level of service is same. Find out input data. What input data we will look. Adjust the demand volumes. You don't have one volume now. You have two volumes. Okay, you have two volumes. One which is on the freeway. One which is from ramp. There are two now. Okay, same thing here. One for the freeway, one for the ramp. Okay, but here the ramp means coming in, here the ramp means going out. So we have more than one demand volume, and you have to do the same thing, VP, find out VP for each, the highway and the ramp. Okay, then we said the influence area is up to how many lanes? 2 lanes. Okay, so this is outside the influence area, so we have to separate them now. So a demand volume which we have total, from there you will separate the one which is for the ramp, which is in these lanes, and the one which is outside the influence. Got it? Okay, sure. Now if there are only 2 lanes, then the entire volume is in the influence. If there is only 1 lane, same, right? There's a problem. He will give the right answer. See? Yes. What's the problem? He is the problem, huh? Freeways don't have 1 lanes. Freeways don't have 1. Okay. I can say if you have 0 lanes, still I will get an answer, right? Okay. So it can either be 2 lanes or more. If the 2 lanes, then the whole section is under the influence. The more than 2 lanes, then the immediate are under the influence. Okay. Which volume will be? So for example, there are 3 lanes. There are 3 lanes. Okay. Which volume will be in the influence area? The one which is coming from the ramp, for sure, right? The one which is coming from the ramp is for sure in this area. Okay. Which one will be divided? The one which is on the freeway. The freeway volume, some of it will be in the influence, some of it will be outside the influence. Got it? Okay. So if there are 2 lanes, then everybody from the ramp, everybody from the freeway in the influence. No problem. More than 2 lanes, then everybody from the ramp in the influence. Everybody on the freeway, some in the influence, some outside the influence. So you have to find out how many are in the influence, how many are outside the influence. Got it? Same thing here. Everybody who is going out from the ramp in the influence, right? Everybody who is on the freeway, maybe, may not be. If there are 2 lanes, everybody in the highway, freeway, in the influence. More than 2 lanes, I have to find out how many. Clear? Clear? Okay. So this is the second step which they are saying. Then find out the capacity of this segment, these segments. How much is the capacity? We have seen the equation for calculating normal capacity, right? The equation which we have used even in this example. So we do some adjustment in the same. So that equation will be used. The basic equation which I showed you for capacity, which we used here, that will still be used because it's still a freeway. Okay. After you do this, then you find out density and find out level of service. Now the interesting thing here is that after you find out density, you find out speed afterwards. Okay, so speed calculation is not similar to what we have done for the basic freeway segment. So that's why it's different. In the basic freeway, we were finding speed and then density and level of service. Here it is reverse. Okay, why it is reverse, we will see it. Okay, so first thing, you find out the input data, okay. Then you have to convert the flow rate. You have to find out the flow rate. So this is your volume divided by this and this. It will be converted to flow rate. Okay. There is something which is missing here. Number of lanes. Can I put it? Lanes of the highway, lanes of the freeway. Should I put it?
It's already two.
It's already two.
For
Not basic.
It's not basic freeway. So why can't I? Okay, my freeway has 3 lanes. Should I put 3 here? But he's saying it's already 2. And one is saying it's 1. The other one is saying it's 2.
This is for one.
Uh-huh.
This is for one lane.
This is for 1 lane. Yes.
Freeway.
Amda will come up with something new. Half a lane. I already have people 1 lane, 2 lanes, already 1 lane, already 2 lanes. Huh?
It's already for the influence area.
It's already for the influence area. So what?
So it's already 2 for the 2 lane.
Already 2. See? Everything is already. Huh? The coffee is ready. He's sitting drinking it alone. Right? Already. See? Everything is already. I started the course. Already have A. Right? I started teaching. I already gave you an F. Right? There is nothing ready here. Okay? The problem is, I told you, some people are in the influence area. Some people are outside the influence area. Okay? So, I don't know how many. Okay? When I do this upon number of lanes, I am dividing it equal. It is not equal distribution. Okay? When you see a ramp, it's not equal distribution there. Because people are coming in from the ramp. Some of those people will be sensible and try to avoid. Okay? And some of us will be brave, bold. Let these people come. I will go like this. Okay? So, it's not equal. That's the problem. It's not equal. I cannot distribute it equally until I exactly know there are 2 lanes or 3 lanes. So, I cannot put it here. I cannot put it here. Anyways. So, this is a general equation which is without number of lanes. And this is not for 1 lane. So, it's not per lane. Volume is not per lane. It's total volume. It's still total volume. But I cannot divide by n because I don't know how many should be divided. Clear? This is the problem. Okay, which brings us to the next step. Okay, so I will take flow rate. Now, if the volume is total, then the flow rate is also total. Okay, so now I will divide. Now I will decide how much will go in the first 2 lanes and how much will go in the third and the 4th lane and so on. Okay, so VF, which is the total volume of the freeway, can be multiplied by proportion of flow in the merged area or proportion of flow in the diverged area. PFM means proportion of flow in the merged area. PFD means proportion of flow in the diverged area. Okay. Now when it is merging, okay, so nobody is going out, right? From the freeway, nobody is going out. It's merging. Okay. So VF, the freeway flow, okay, multiply by the percentage of people who are in the influence area. The remaining is outside. Okay. So they call it V12. Why V12? First lane, second lane. Okay, 2 lanes, right? So they call it V12. Okay. So this will give you the flow in the first 2 lanes. Okay. And if there are only 2 lanes, then this is how much? If there are only 2 lanes, then this factor is 1 because everybody is in those 2 lanes, right? Okay. And if there are 3 lanes or 4 lanes, then this factor will be less than 1, right? Clear? Some part of it will be on the ramp, in the influence. Okay. Now, if it is a diverge area, now in diverge area, what is happening? People are going out, right? People are going out. People who are on the freeway, some of them will be in the influence area, some of them outside. Okay. And there are some people who are already on the freeway, but they will go out from the ramp, right? They will go out from the ramp. Right now they are on the freeway. So that's why I have to subtract them. Okay? Clear? Okay. This is diverge. So people who will be on the ramp, they are on the freeway right now. So I will subtract them. Okay? I want to calculate how many people are in the first two lanes of the freeway. Ramp, I know everybody on the ramp is on the influence area, right? Okay, so ramp is not a problem. I want to know how many people who will remain on the freeway are in the first two lanes. Okay, so VF, which is the total, minus VR, which is the ramp. Okay, so percentage, and again, if there are two lanes, this factor will be 1. Okay, now PFM and PFD. Okay, already mentioned. Okay. Okay. Pay attention. 4-lane freeway. How many lanes each direction?
2.
If there are 2 lanes, then the factor becomes 1. 6-lane meaning 3 lanes each direction. So the factor will be 1 of them. 8 lanes, 4 each direction. Factor will be this one or this one. Okay? How do we decide? So if I'm here, so if I have 6 lanes, I have how many options? 1, 2, 3. I have 3 options. Okay, PFM can be equal to this, or equal to this. Okay, which option I will select? It will come from this table. Okay, and before I go into this table, what we are using here? To find out PFM, I want what? VF, which is the flow on the freeway. VR, flow on the track. Then you see SFR. SFR is the free flow speed on the ramp. SFR is free flow speed on the ramp. Okay. Then we have L up. Okay. L up means length to the previous ramp. Distance from this ramp to the previous ramp. Okay, L up, and L down means distance to the next. Upstream, downstream. Up and down is upstream before, downstream after. So I need 3 things here. I should know the 2 flow rates. I should know the speed on the free on the ramp, and I should know the distance to the previous ramp. Clear? Okay. So you see L up here and you see L down. L down means what? Distance to the next one. Okay. Then you see something written as LA here. LA means acceleration ramp or acceleration length. Acceleration length. What is acceleration length?
Isn't the influence correct?
This one. When people enter from the ramp, you give them something, some extra distance for merging. This extra distance is known as acceleration length. Okay, and for going out, same thing. You give them some extra distance for diverging. This extra distance will be called as deceleration length, LD. Okay, so this I'm talking about this one. Okay, this extra lane which is with the ramp. Okay, so if it is an on ramp, we call it acceleration lane, LA. If it is off ramp, we call it deceleration lane, LD. Got it? There. Okay. Okay. What is left now? SFI I told you. And we only need VD. Okay. So VD is used there in one of the equations, and VD means the flow rate on the downstream ramp. Flow rate on the downstream ramp. Okay. Now, how will we select the equation? I'll just give you one case. For example, you have a segment which has an on ramp. Okay. Before this ramp, you have an off ramp. Before this, off ramp. Okay. And after this, you have an on ramp again. So I'm doing it in my area. My area is, let's say, ramp X. So before ramp X, there is an on ramp. After ramp X, there is an off ramp. Okay, now come here. This is your ramp. Which ramp do I have? On. Okay, I'm doing it for on ramp. Before me, I have what? Yeah? Upstream is what? On or off? On ramp. Okay, upstream. This one, it could be this one, this one. The three cases, right? What is my off stream ramp? This says no, none. So this cannot be my case, right? This one says on. This is not my case. My case is what? This one. Okay. So now they are saying what? Use equation. Equation number is written there. Okay. So you will look for your case and then come here and find out which equation to use. Clear? Okay? Yeah. Now in some cases they are saying you have to check these two values as well. Okay? So these values are what? Distance between the two ramps. DS, distance between the two ramps. Okay? So whichever ramp you are talking about. Okay? Your ramp and the immediate ramp, before or after. So the distance between them is D. Okay? And then we have LEQ. LEQ will come from these equations. Okay? These equations are for upstream off ramp. OFR is off ramp. And this is what? Downstream off ramp. Okay? So you will calculate LEQ from here if you need it. If you need it. You can see, if I'm here, I don't need LEQ. If I'm here, no need. Here, no need. Here, no need. Okay? If you are here, then you have to check. Okay? I can use equation 5.28 if this is the case. I will use equation 5.3 if this is the case. Clear? Okay? So, it's confusing, I know. Okay, we will do example, but obviously not now. So that those two tables were to find out the proportion of flow in the merge influence area. And these are for the proportion of flow in the diverge area, PFD. The factors are the same. All of them are the same. You can see LA here, LD here, VU here. VU means flow in the upstream ramp, and so on and so forth. Okay, the explanation is given here. Okay, so inshallah on Sunday we will do, I think there are some examples which we will do. Okay, any question?